Hello folks, just a quick video on some prime numbers and the factors. I'm going to run you through a couple of examples which hopefully might help you understand how all these primes interact with their numbers. So let's have a look at the first example, the prime factorization of 36. So what we're going to do is look at this particular algorithm, a particular way of doing it. So let's take 36 and we have to find the lowest prime number that will divide into 36. And no doubt you're saying, well, that's 2. So you chuck 2 out to the side and you divide 36 by 2, which of course is 18. And then you just do this all over again. So the lowest prime number that goes into 18, which we know is 2, and then we divide it again. So 18 divided by 2 is 9. Now we do it again. So 9, lowest prime number that goes into 9. Well, 2 doesn't work anymore, so let's go up. 3. 3 works, good. So let's take a 3 out. And 9 divided by 3 is 3. So we actually finish with a prime number, and that's our signal to stop. We can't go any further. So what we're doing now is saying 36 in terms of a multiplication of all prime numbers is 2 times 2 times 3 times 3. Let's look at another example. Here's 20. So let's do it again. So 20, and then the lowest prime number is 2. So 20 divided by 2 is 10, and then let's do it again. 10, lowest prime number is 2, that goes into 10, and divide that, and we finish with a prime number. We finish with 5, so we're done. And so therefore 20 can be expressed as 2 times 2 times 5. Now let's take this one step further. Can you use this algorithm to find the highest common factor? And now remember what the highest common factor is. The highest common factor is the biggest number, the highest number, that will divide evenly both into 20 and 36. Highest number that divides into those two numbers. Well, let's see in action with this algorithm. So this is the prime factorization of 20 and 36. Those are the ones we just found out. So the highest common factor has to be everything that is common to both. Well, by looking at those two numbers, the primes, can you see what's common to both? And no doubt you're staring right at those 2's. That's common to both. Everything else is different. And so what we can actually say is the highest common factor of 20 and 36 is just 2 times 2, which is 4. And it becomes a very efficient way of finding this highest common factor. You're no longer guessing, you're no longer just trial and error, you're no longer having to do big lists of multiples and just see all factors and seeing what's common. Here you can go straight to the answer because you can see what's common. So the way of doing it with the algorithm is you're actually just doing the same thing as we did before right at the start, but this time you're doing it with 2 numbers. So you're saying, now what is the lowest prime number that divides into 36 and also divides into 20? Oh, well, of course 2 does. So let's put 2 out the front and we'll divide both 36 and 20 by 2. So 36 divided by 20 is 18, 20 divided by 2 is 10. And we do it all over again. Lowest common multiple that goes into 18 and 10 works out to be 2 again. So divide them, and it works out to the answers to be 9 and 5. And then you know that's where you got to stop. How do you know when you got to stop? Well, of course, there's nothing common between 9 and 5. You're done. And so those 2's at the left-hand side, that is all that is common in terms of primes between 36 and 20. Well, that has to be the highest common factor. Whatever is out on those left-hand side, try to see those as common to both numbers. And that's how you can use this algorithm to find the highest common factor. To finish off, let's look at the lowest common multiple. Lowest common multiple of 20 and 36. Well, here we go. Here are the prime factors again. Now to find the lowest common multiple, let's understand what that means. That is the lowest number that 20 and 36 will both divide into evenly. So now actually 20 and 36 are the factors of this number. Now what is the lowest number that 20 and 36 will divide into? Well, from a prime factor's point of view, the lowest common multiple has to have everything that's common between the two numbers and everything that's not. Now what am I talking about? Well, the lowest common multiple will have to have 2 2's in it, but it'll also have to have everything else that's not common. So it'll have to have the 2 times 2, but it'll also have to have the 3 times 3 coming from the 36, and it'll also have to have a times 5 from the 20. So therefore the answer is all those multiplied together. So let's take a second to have a look what that means. The lowest common multiple. That's everything that's common and everything that's not. Now notice you don't need to have 4 2's, you just have to have 2 2's, as much as what's common. Let's see that again in the algorithm though. So we've got 36 and 20. Let's do the exact same thing that we did before. So we've got 2, that's common, divide both by 2, take another 2 out, divide both by 2. But this time now, to do the lowest common multiple, remember it's everything that's common, which is the 2 2's, and everything that's not. Well, what's not common between the two numbers is the 9 and the 5. And so the lowest common multiple is everything multiplied together. It's 2 times 2 times 9 times 5. But remember that 9 that you can see there, that actually is still just what we had before. That's just 3 times 3, which works out to be 180. And the sweetest part about using this particular algorithm for the lowest common multiple is that when you actually have to multiply all the numbers on the outside, just conveniently enough, it actually works out to be an L for the lowest common multiple. Pretty sweet. Folks, I hope you found that a little bit helpful, and best of luck. Bye.